Coffee's getting cold because I've been down here too long. But man, is it delicious because it's Dunkin' Donuts coffee and it makes me do math better. So you'd be a better math student if you drank Dunkin' Donuts coffee. I know. Talent in the making. Gosh. All right, kiddos, let's hear it. You're here for Unit 1 of Algebra, Linear Relations and Functions. Day 6. Day 6. My name is Mr. Krause. You can call me Mr. Krause, or you can call me Mr. Answer Key. These are your notes for Unit 6. I'm going to speak in a weird language with an accent today. I do terrible accents. My wife always makes fun of me and my accents. All right, let's talk about piecewise and relations and functions. Piecewise relations and functions. Really, piecewise functions are just multiple relations or functions. I hate writing the word functions. Put together to make a new relation or function. So we're going to just take a whole bunch of pieces and put them together. We're like, you know what, I want this little piece. And then I want this little piece. And then I want this little piece. But the deal is you don't take the whole function. You just take a piece of a function. Like a piece of this one, and I'm going to take a piece of this one. I'm going to take a piece of this one, put them all together, make some funky. So here we go. Here's a little funky one. So this has two pieces. It has a linear piece, y equals x plus 2. Now, it's got a y-intercept of 2. But notice we're not including that part in the graph. So notice this stops right here at negative 2. So this piece is going from negative infinity that's negative 8. That's awful. It's going from negative infinity all the way up to and not including negative 2. Now this piece should become as no surprise that it's an absolute value. Notice the absolute value. It's got a rate of change of down 2 over 1. We move left 1 and up 3. So what is this? Ooh, I got to fix this. That is wrong. Ooh, we got a mistake there. Man, I got another mistake. Oh, shoot. I changed this problem because I wanted something a little bit more exciting. So that's not what that's supposed to look like. Right there is supposed to be negative 2 absolute value of x plus 1 plus 3. It's like I got rid of this whole piece and I just put x plus 3. That's kind of silly. Now here's the thing. You define the functions here and you define here the restrictions on the domain. In other words, what is the piece? Where do you want to look for this piece? So the first one is x plus 2. And that's all the way here and going in this direction. So it's from negative infinity, but stop at negative 2. So the easiest way to say that is x is less than negative 2. Now, do you see how it's an open circle here? So it's strictly less than. So for all values that are x is less than 2, you're going to draw this function. Now, for all values greater than negative 2, now we want to draw this absolute value function. So this is just going to be x is greater than, but equal to negative 2, because you notice it's got a solid circle here. So again, the function goes first, and then the restrictions on the domain go second. Come on, we'll practice. All right, so now I'm going to give you nothing. I gave you nothing. But what we have here is 3 lines. We have 3 lines. Sorry, I got to adjust. All right, so this is the line y equals negative 3. I know you probably haven't seen a y equals line, but y equals lines are these horizontal lines. This line here, let me pick a funkier color. This line here, and this cone's just too thick. This line here is y equals, now it's got a slope of up 3 over 1, so positive 3x plus 3. And then this piece here has a slope of negative 1, so it's negative x plus 3. So those are your 3 pieces. So those are the defined functions. So the functions go first. So y equals negative 3. Now notice I'm not putting y equals, right? Because this is the f of x that goes with each piece. So it's almost like y equals this, y equals, so we just don't put the y equals. All we do is put the right side of the equation. f of x equals 3x plus 3. And f of x equals negative x plus 3. Comma, comma, comma. Now we put the restrictions on the domain. In other words, where do you see the piece? Where do you see this piece? Well, I only see this piece from -4 to -2. So -4, anytime it's a chunky piece like that, it's always going to be x in the middle, and you always write less thans. Less than x, less than -2. Now, you got to be careful. Notice that these are solid circles, correct? So I need to put a less than or equal for this one, and a less than or equal for this one. Now, you're going to find out you didn't necessarily have to put a less than for equal for that. I'll explain that in a second. So, where's the next piece? The next piece starts at -2 and ends at 0. So -2 less than x less than 0. Remember, those are x's in the middle. Anytime it's a chunk, start, end. X is in the middle, always lessens. Now, because I used -2, because I chose to put this equal sign here on -2, I cannot put it here. It can't be in two different places. So just pick one. It doesn't matter. I could have put it in the middle one and not put it up here. It doesn't matter. And then I'll put the less than or equal to up there. But because I put the less than or equal to for this one, I'm not going to be able to use it for this one. Okay? Now this one starts at 0 and ends at 4. So 0 less than x less than 4. Now, because I already put the equal to here, I cannot put it here. And notice this already is an open circle, so that's got to be maintained, and that's a 4, not whatever the heck it looks like there, 4. We're going to do piecewise functions a couple of days, so don't fret on these and don't freak out about these. All right, we've got 3 pieces again. Now, these are a little bit trickier, but let's just do this. Ding, 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 ding. So if I extended that, that's the line y equals -x minus 3. This has a slope of up 1 over 2, so this is y equals 1/2 x plus 1. And then this one's a little bit funky, but we just extend. So this is y equals negative, let's see, down 1, 2, 3 over 2. So -3 over 2x, and then plus 5. So those are your functions. Those are what goes right here. So we got -x minus 3, comma. We've got 1/2 x plus 1, comma. And we've got -3/2 x plus 5, comma. Now we put the domain pieces. The domain pieces go here. Where did you start? Where did you end? So let me erase this. I'm going to erase all this so I can clean it out here for you. We have clear delineation points. This one starts here and ends here. So this is -4 less than x less than -2. Oop, got a closed circle, got to put an equal to. Got an open circle here, so we're going to leave it. Now the second piece starts at -2 and ends at +2. So -2 less than x less than 2. And I think this says -2, I hope. Closed circle here, so equal to, but this one's got an open circle. All right, actually they're all like that, isn't that weird? And then this one starts at 2 and this one ends at 4. So 2 less than x less than 4, and this is going to get the equal to. All right, now let's work backwards. Let me give you the functions, and you have to draw the picture. All right, so just think about what these mean. The first one really means y equals 2. The second one is y equals -2x. And the third one is y equals -2. All right, so let's start with the first one. This would be the first line right here. Y equals 2. It's a horizontal line, y equals 2. Now, I just put it nice and lightly in there. You can do it nice and lightly with your pencil to start, just to put a light pencil in there. Because what we're going to want to do is we want to think about, where does this start? where does this end? So it starts at -3 and it's a closed circle. So -3, closed circle. That means I don't need any of this. I'll just erase that. Nice and light. And we're going to end at -1, closed circle. Connect the dots. And then I don't need any of this. We'll get rid of all this. All right. So this one is the line y equals -2x. So let me do this nice and lightly. I'm going to do it in a nice, lightly in a different color. So starting at the origin, because it's the y-intercept, I'm going to go down 2 over 1. Down 2 over 1. So that's all this. Now, where am I starting? I'm starting at -1. Well, there's already a point there, so we're going to leave it. Now, someone was like, well, it's got to be an open point, but there's already a closed point there. So I don't need any of this. And it's going to end at 1, and we got an open circle there. So we'll put an open circle there because we got this nice little open circle. And we connect the dots. And then we don't need this. So if you do it nice and light, you can erase your like work. All right, then the line y equals -2 I'll do in green. Can't do that. Y equals -2 looks like this. Oops, kind of dark. Yeah, but this one tells us we're going to start at 1, closed circle. Well, there's already a point here, but it's open, but now it's closed. And we're going to end at 2. And connect the dots, and then we get rid of everything else. Oops. Closed circle right there. All right, that's what that one's going to look like. All right, I'll be right back. Coffee time. Could you feel the taste when I went, Could you feel how good it was? Oh, Dunkin' Donuts coffee. All right, again, what we have here is y equals -x plus 1. Let's just graph that. Y-intercept of 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and then we just go like this. If you just put these dots in, it's actually quite a little bit easier. Put them in light, though. Put them in real light so you can erase them. Starting at -4, closed circle. So here's -4, closed circle, so I don't need that dot. We're going to end at 0, open circle. Now remember, it's the x of 0, not where the y is 0, where the x is 0. We want all of that. And notice it's an open circle, so I'll get rid of my work. Nobody saw it. And then the next piece is y equals 4x minus 3. So we have a y-intercept of -3. And we're going to go up 4 over 1. Up 4 over 1. Now what does it tell us to start? It tells us to start at 0 with a closed circle. So, I already got a closed circle there. And we're going to end at 2 with a closed circle. And then we just connect the dots. That's it. Let's do another one. Maybe that's it. Nope, we got another one. Oh, the absolute value function. So the absolute value function is actually 2 linear functions together. This piece is the line y equals +x, and this piece is the line y equals -x. So I could, if I wanted to, I could rewrite an absolute value function like this. I could say, okay, y is equal to, or absolute value of x, if I said, this, the absolute value could be equal to -x. Now, where is it equal to -x? Over here. So for x is less than or equal to 0. And where does it equal +x? Oh, it equals +x for x is greater than 0. Now, notice I can't put the equal to in both, so I just chose the first one. It made no difference. It doesn't make a difference to me either, whichever way you do it. But that's how I could define an absolute value function, as a positive and a negative. All right. So what we're going to do is we're going to write this absolute value function as a piecewise function. But before we do that, write the absolute value function below as a piecewise function. But I want the equation of it. So if you were just telling me g of x, you would say this thing is equal to, first of all, it's going down. And it's got a slope of down 2 and over 1, so down 2. It moved to the right 1, so x plus 1. And it moved up 5, plus 5. Now, this should not be plus 1 for those of you screaming at me right now. I just figured it out. Because we moved to the right, it's really -1. Remember, it's backwards. So if I asked you just to write the linear function of it, it would be that. Now you could always test these to see if you're right. You can come over to your calculator, hit the graph button, and then type in -2 absolute value of x, where the heck is x? X minus 1, and then plus 5. So we'll look at that. There's that. Now, I'm going to show you in a second how you do piecewise functions on the calculator. So you got to do a big curly bracket. Now we only have 2 pieces, so that's okay. This piece is relatively straightforward. This piece right here is y equals up 2 over 1, so 2x plus 3. So 2x plus 3. And we're going to do that for x is less than or equal to 1. Now this next piece isn't quite as easy because we don't know exactly what the y-intercept is, but we could figure it out pretty quick. Over 2 up 1. I'm here at 5. So over 1 up 2, excuse me, over 1 up 2, over 1 up 2. So my y-intercept up here would be 7. So this is the line y equals -2x plus 7. So -2x plus 7, and we're going to do that for all values, x is greater than 1. Now let me show you how you use your calculator to graph a piecewise function. It's actually relatively simple, if I can find my calculator. So what you do is you hit the tab button, because tab just says I'm going to graph something else, and then you go in the key of everything, right here, the key of everything. It's right next to the 9. And you go over here to this one. Actually, it really doesn't matter. I can use one of these. I guess I'll just use this one because it's only got 2 things. Oops, shoot. Escape. So you press tab, hit the graph button, click on that. Okay, so the first piece is 2x plus 3, and we're going to do that for x. Now, greater than or equal to, you see the equal to sign? We're going to go control equals, and we want the one that's less than or equal to 1. And then we're going to use -2x plus 7, and we're going to do that for x greater than 1. Now, if I did this perfectly, it should graph a perfect line, red line, over this blue line. Hopefully I did it correctly. I did not. Let's see if we can find my mistake. Can you guys find my mistake? It's pretty simple. It's right here. What did I forget? I forgot the x. There we go. So you see how the red line graphs? So we can write it as an absolute value function, or we can write it as a piecewise function. Clearly the absolute value function is easier, but you need to be able to do both. Okay. Write as a piecewise function. So f of x equals, this piece here is the line y equals x. This piece here is the line y equals 1. Now, when do I use y equals x? I use y equals x from -1 to 0. So -1 less than or equal to x less than 0, less than or equal to 0. Now, they're both less than or equal to because we got solid dots here. Now, when do I equal 1? Well, I equal 1 from 0 less than x less than or equal to 2. Starting here at 0, ending at 2, closed circle on the right, open circle on the left. That's why we have the equal to. Now, it wants this one written as a piecewise function too, so it shouldn't be too difficult, I hope. So let's do this as m of x. M of x is equal to, now this slope is up 1 over 2, so that's positive 1/2. Positive 1/2 x. Now what's the y-intercept? Minus 1.5. Okay, and then the other piece is going to be -1/2 x. Now we've got to find its y-intercept. We've got to keep going. Looks like it's -2.5. So minus 2.5. Now, that's not good enough. You got to give me the domains. And what's the cutoff? The cutoff for, where's my pen? The cutoff for these domains, remember, it's always the x values, is right here at -1. So we're going to have this piece for when x is greater than or equal to 1, -1. And we're going to use this piece for when x is less than, don't put equal to, negative 1. You just got to pick. Which one do you want to have the equal to? It doesn't matter. Makes no difference. Just choose and just do it. Just make sure you stay consistent. All right, that's it. Wait, maybe. Oh, no, we got more. Oh, man, that's cray cray. All right. Is this a function? Yes. Passes the vertical line test. Is it a one-to-one function? No. Since it is not a one-to-one function, we can immediately come down here and say its inverse is not a function. What's the domain? The domain is from bracket negative 4, comma 4. I don't know what it is about 4s. Bracket. Range, the lowest y value is negative 2. The highest y value is 2. What's the x-intercept? We got one at 4, and we got one at negative 2. Negative 2 and 4. Curly brackets, because it's a list. What's the y-intercept? It's at 2. One time we use y values, the other time we use y values are right here. Well, obviously we use y values for y-intercept. The other y values is right here for range. Where is it increasing? It's increasing from here to here. So it's increasing from x values from negative 4 to 0. So from negative 4 to 0. Never include endpoints on increasing or decreasing. At this point, it's doing neither increasing nor decreasing, but starting from 2 and going to 4, it's decreasing. So from 2 to 4, but parentheses. Remember what less than 0 means. Less than 0 means negative. It means below x-axis. Where is it below the x-axis? Well, it's only below the x-axis in this little area right here. X values. So from negative 4 to negative 2. Negative 4. This should be a bracket. So at negative 4, it's less than 0. All the way up to negative 2, but don't include negative 2, because at this point it's equal to 0. So that's part of this answer, negative 2. There's another one right over here, 4, right? All right, this means positive or above x-axis. Well, I hope you can agree that it's above x-axis from here to here. All of this is above. So that's from negative 2 to 4. So negative 2 to 4. But at negative 2 and at 4, it's equal to 0. So put parentheses. Do not put brackets. All right. We're almost done. Min and max. Well, remember, now we've got min and max. That's where we're going to use our y values. So what is the lowest y value? The lowest y value is right here at negative 2. And what's the highest y value? That's up here at positive 2. All right. Last problem. W. Is it a function? Yes. Do you know what? It's also an even function. Did you notice it's an even function because it's symmetric with respect to the y-axis? It's an even function. Is it a one-to-one function? No. Remember, vertical line test for function, horizontal line test for one-to-one function. What's the domain? Negative infinity, positive infinity. Goes forever and ever left, forever and ever right. What's the range? Starts at 0 and goes up, right? The lowest y value is here, 0, and it goes up. All right, what's the x-intercepts? It crosses the x-axis at negative 1 and 1. The y-intercept is 2. Now this one's going to be hard. Increasing. It's increasing here and here. And remember, anytime you have something in two distinct places, that's an OR. So from negative 1 to 0, remember we're still using x values. So from negative 1 to 0, do not include endpoints, or, and then starting from 1 to infinity. 1 to infinity. Now it's decreasing in this zone, decreasing here, and it's decreasing here. So from negative infinity to negative 1 do not include the endpoints. Sorry, now we're probably back behind my head again. Or from 0 to 1. Okay, anytime it's in two different places, don't forget it's an or. Again, less than 0, negative, below. Greater than 0, positive, above. So it's never negative, so that's just empty set. It's equal to 0 at negative 1 and 1. Now the positive is a pain in the neck. A positive is a pain in the neck. So it's positive here, but not at this point. It's positive here, but not at this point. And it's positive here. So it's positive in 3 different places. So that's a 3-place OR. That's 2 ORs. So let me see if I can get this in here. See if you can see that up there. So from negative infinity, I'm going to do this in a different color because that's too big. So from negative infinity to negative 1, don't include negative 1, or, and then starting at negative 1 again to 1, but don't include negative 1 at 1, or starting at 1 and going to infinity. So in other words, at negative 1 and 1, it didn't count, so you had to kind of leave it out. Is the inverse a function? No, because it's not a one-to-one function. And then min and max, don't forget, min and max are our y values. So the min value is, the lowest y value is 0. So the minimum is 0. And the maximum is infinity. All right, kiddos, that is the end of day 6. And here comes the homework, so get ready. All right, catch you on the flip side, kiddos.